So the last video we were walking through question 6 on the homework, and I sort of explained that it's important for us to use this formula for the population, the confidence interval for the population mean mu. And we walked through some of the pieces and what this means, and then we specifically worked out how to calculate them in R. I'd like to do the same thing, but this time I'm going to bring over my graphing calculator and make sure that everyone feels comfortable doing this on a graphing calculator as well. So here's my calculator. I'm going to have to pull up the data again and enter it all in. So here we go. This is going to be a process. But here we go. So if I press stat and then edit, I'm going to have to put all the numbers into list 1. I have some data in there from a previous example, so I'm just going to press clear and then enter to get rid of it. And then I'm ready to enter in all these numbers. Fingers crossed I don't make any mistakes. We have to watch this carefully. So 39.8, 46.0, 66.5, 40.2, 61.4, 32.1, 46.8, 35.4, 50.9. Oh, no, I did those as 2 separate. Okay, where were we? 46.8, 35.4, enter, 50.9, enter, 57.2, enter, 59.1, enter, 55.3, enter, 58.5, 51.1, 38.6, 40.5, 93.1, 51.2, 72.9, 49.3, and 50, oops, not 40, 56.6. Okay, so fingers crossed I've entered them all in right. Maybe I'll just double check them. 56.6, 49.3, 72.9, 51.2, 93.1, 40.5, 38.6, 51.1, 58.5, 55.3, 59.1, 57.2, 50.1, oops, oh no, 50.9, 40, 35.4, 46.8, 61.4. Okay, I'm feeling good. All right, so they're all entered in there, and I think I've done that correctly. Okay, so to remember to get your summary statistics, so to get X bar and S and N, we get that from one variable statistics. So press stat and then over to calculate and then 1 for one variable statistics. Okay, and press calculate. Okay, it should spit out lots of different things, but X bar, so you should make note of these somewhere on your page. So hopefully you've got some paper somewhere. So X bar is 52.5. Okay. My standard deviation comes from SX on the calculator. So make sure you're using SX and not the sigma X because this is a sample. So we need the sample standard deviation. So it's 13.99210.492. Okay, notice that I write down as many decimal places as I can, and I'm going to use those in my calculation just to make sure that, nothing is happening there. And my N is 21. Okay, so those are all of those pieces. To get the critical value, so let me just pull up here. So this was the work that I talked about in the last video, but essentially if they've asked us for, it was a 90% confidence interval here, okay? So we worked out that 1 minus alpha is 90%, that's the area in the middle. So the area in the two tails, or the error rate, must be 0.1. I divided it up so the error falls in each of the two tails, okay? The degrees of freedom is 20, that comes from n minus 1, and we're looking for this particular value. This is the critical value. the value that falls on the t distribution with 20 degrees of freedom, where the area to the right is 0.05. To get this on a calculator, it's the function inverse t. Okay, inverse t, you always have to tell it the area to the left. So I'm going to do 1 minus the 0.05 to get the area to the left of my critical value, and then I have to tell it the degrees of freedom. Okay, so I'm just going to go to my calculator here and plug that in. So to get to inverse t, it's in my distributions menu. So second distributions, and then scroll down to inverse t. If you don't have an inverse t on yours, there is some instructions on Piazza about how to actually get an inverse t. You have to program it into your calculator. So there's inverse t. The area to the left is 1 minus 0.05, and my degrees of freedom is 20. And so I get for my critical value here, there it is, and I'm going to write it down with as many decimal places as possible. So 1.724718218. Okay. Then from there, you're ready to sort of work it all out in one calculation. So again, I'm going to type this in. So 52.5, that's my mean, minus, oops, not plus, minus the critical value, so 1.724718218 times the standard deviation. So I'm going to type that all in, 13.992104992 divided by, and then the square root of n. So in this case, it's the square root, so second square root of 21. Okay. And when I press enter, that's going to give me the lower bound, so 47.23 if I round to 2 decimal places. That's the same thing that I got when I did it in R. Okay. And then here, to get the upper bound, I like to sort of cheat this. So if I scroll up and press enter, that's going to enter in the same code all over again. And then if I scroll over, I can change that minus sign to a plus sign. It saves me from having to enter it all in again. But you could type it all in again. Too much. Doesn't work as easily on a computer, I don't think. There we go, plus, and press enter. So then I get 57.76. Again, if I'm rounding to 2 decimal places, because this is a 6, because it's bigger than 5, I'm going to round up to 57.77. So that's what I would put in here. So I'm getting the same answer whether I use my graphing calculator or whether I use R. Hopefully that helped.